Dear ladies and gentlemen, good morning. Thank you to each and every one of you for following this presentation numerical study of hybrid photovoltaic solar thermal system in transient condition. In the first, I start by studying the problematic, then the illustration of our study. Afterwards, I present the results, then I finish by conclusion. In problematic, we have that the increase in temperature of the PV model leads to a decrease in electrical efficiency. Temperature of PV model is increased by absorbed radiation which isn't converted into electricity, so decreasing the electrical efficiency. To increase the electrical efficiency of PV panel, cooling needs to be done. Illustration. In figure 1, we have front view of the PV sheet and the PVT sheet. In the PV system, we have glass cover, air gap, PV module, and insulation. In the PVT system, we add absorber plate and the tube and fluid to decrease the temperature of the PV layer. We have here basic characteristics and specification of the PV and the PVT. For each layer, glass cover, PV, absorber, tube, and insulation. Figure 3 presents the irradiation and the ambient temperature as a function of solar time during January 24th, 2020. The maximum temperature value have reached is 24 degrees C and the maximum irradiation is 743 watt per square meter. Figure 4 also presents the irradiation and the ambient temperature as a function of solar time in another day in March 11th, 2020. The maximum temperature value have reached is 38 degrees C and the maximum irradiation is 853 watt per square meter. In the results for photovoltaic cells temperature, we have here in figure 5 variation of the temperature according to solar time of the PV panel for the evaluated system. In January 24th, 2020, we have decreasing of the temperature of PV by 6 degrees C when we use the PVT. The variation of the temperature in another day in March, we have decreasing of the temperature by 6.44 degrees C when we use the PVT. For the results of electrical efficiency, we have in this figure variation of the electrical efficiency of the PV panel versus solar time for the evaluated systems during January 24th. We have enhancing of the electrical efficiency by 0.54% when we use the PVT. For the variation of the electrical efficiency in another day in March, we have also here the enhance of the electrical efficiency by 0.54% when we use the PVT. Conclusion. In this study, the comparative electrical performance of PVT and PV systems has been investigated through simulation, one-dimensional mathematical model for simulating the transient processes of PVT and PV systems is developed. The modeling is conducted during 10 hours of 2 days, 24th of January and 11th of March 2020 in Ouarzazte, Morocco. It has been found that the PVT reduces the temperature of PV cell by about 6 degrees C. The enhancement of the electrical efficiency was 0.54% compared to the conventional PV according to the used simulation parameters. Thank you so much for your attention.